Alright, today we are talking about properties of trapezoids and kites. Alright, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, one pair of parallel sides. The bases of a trapezoid, they are the parallel sides. So here's our trapezoid here. This is base 1. And this is base 2. And they are parallel to each other. Okay, and sometimes we abbreviate that with B sub 1 and B sub 2. Alright, the base angles. Alright, a trapezoid has two pairs of base angles. Each pair shares a base as a side. So, here's one pair of base angles, and here's a second pair of base angles. And they don't necessarily have to be congruent. I'm marking them the same to show you that these are the base angles that go together. Alright, and those are the pair of base angles that go together, but they're not necessarily congruent to each other. Okay, and we'll talk more about that and go through problems. Legs of a trapezoid. The non-parallel sides of the trapezoid are called the legs. So here's a leg, and here's a leg. Alright. And an isosceles trapezoid, just like an isosceles triangle, two sides are congruent. With an isosceles trapezoid, the two sides that are congruent are the legs. So when you have an isosceles trapezoid, the legs are congruent. Okay? Now midsegment, we've seen that term before, midsegment. Alright, if you remember back to a triangle, a midsegment connected the midpoints of two sides of the triangle. Midsegment still connects the midpoints. Alright, if we're talking about the midsegment of a trapezoid, it connects the midpoints of the legs. Okay? And lastly, a kite is a quadrilateral that has two pairs of consecutive, alright? You gotta know what that word means, consecutive. Alright, congruent sides, but opposite sides are not congruent. So opposite sides aren't congruent, but consecutive sides are. So consecutive means right in a row. So these two sides could be congruent, and then these two would be congruent to each other. But opposite sides are not congruent to each other in a kite. So a trapezoid and a kite are not parallelograms. Okay? They're not parallelograms. Alright, show that CDEF is a trapezoid. Alright, so again we have the coordinate plane. Alright, how would we show that this is a trapezoid? Well, the definition of a trapezoid is that it has one pair of parallel sides. And in the coordinate plane, when you're showing sides are parallel, you're using the slope formula. Alright, now, which sides do we think would be parallel? Alright, it looks like segment ED and segment CF. Alright, so I'm going to find the slope of segment ED, which is 4 minus 3 divided by 4 minus 1. 4 minus 3 is 1, 4 minus 1 is 3, so 1/3. And then I want to find the slope of segment CF, which is 2 minus 0 over 6 minus 0, which is 2 over 6, which is equal to 1/3. So slopes are the same. That means segment ED is parallel to segment CF. Therefore, it is a trapezoid. Okay? Now the other thing we should look at is, okay, is this a parallelogram versus a trapezoid? We'd have to look at the other two sides, segment CD versus EF, and are those parallel or not? Because in a trapezoid, there's only one pair of parallel sides. Okay, those are parallel, but are these parallel or are they not parallel? So segment CD, 3 minus 0 and 1 minus 0, that's a slope of 3 over 1 or 3. The slope of EF, segment EF, that's 4 minus 2 over 4 minus 6. We get 2 over negative 2, which is negative 1. So they are not parallel, so yes, this is a trapezoid. Alright, an isosceles trapezoid. Alright, again, it's a trapezoid, so it has one pair of sides that are parallel, the bases. Alright, it's isosceles, it has two sides congruent, which are the legs, A, B, and CD. Alright, and when you have an isosceles trapezoid, each pair of base angles is congruent. Alright, so angle A is congruent to angle D, and angle B is congruent to angle C in this diagram. Okay? If a trapezoid has a pair of congruent base angles than it is an isosceles trapezoid. Alright? If we know we have one pair of base angles that are congruent, the other two will be congruent, and it is an isosceles trapezoid. Okay? And then lastly, alright, a trapezoid is isosceles if and only if its diagonals are congruent. Alright, trapezoid ABCD is isosceles if and only if segment AC is congruent segment BD. Alright, a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Alright, so it is an isosceles trapezoid. Knowing that tells us a few things. Find the measure of angle N, L, and M. Okay? Well, it's an isosceles trapezoid. That means what about the base angles? Base angles are congruent. So we know that angle K is congruent to angle N. And the measure of angle K equals 50 degrees. So the measure of angle N then is 50 degrees. Alright? Now, if we think back to chapter 3 here, we got our parallel lines here. Here's our transversal. We have a 50 degree angle here, and this angle here have what kind of angle pair relationship? And those are consecutive interior angles. And when you have parallel lines, consecutive interior angles are supplementary. So angle K plus the measure of angle L has to equal 180. K is 50, so the measure of angle L has to be 130 degrees. And again, we have an isosceles trapezoid, so we know our base angles are congruent, and we know that angle L is congruent to angle M, and the measure of angle L is 130. Well, that's also the measure of angle M. Okay? Alright, mid-segment. Again, it connects the midpoint. So point M is the midpoint of segment AC. Segment AM is congruent to segment CM. Point N is the midpoint of segment BD. Segment BN is congruent to segment DN. So yeah, those 2 points are midpoints. Now, segment AM is not necessarily congruent to segment BN. They're not congruent this way. Okay? They don't have to be. But these two are congruent and those two are congruent. So we have a mid-segment. What are the characteristics of a mid-segment? Alright? The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So segment MN is parallel to segment AB, and segment MN is parallel to segment CD. It's parallel to the bases, and it's half the length of the sum of the bases, the length of AB plus the length of CD. Again, sum means add. Bases, those are our bases, so we add our bases and we take half of that. Alright? Knowing that here, alright, in the diagram, segment MN is the mid-segment of trapezoid PQRS. PQRS. Find the length of MN. Alright, so the length of MN equals 1/2 the length of length PQ plus length SR. Substituting the values that we know. Well, we don't know this one. Equals 1/2, that's a number. PQ is 16, plus SR is 9. So length of MN equals half of 16 plus 9 is 25. So length of MN is 12.5 inches. Okay? A kite. Again, a kite, consecutive sides, 2 pairs of consecutive sides are congruent. A quadrilateral is a kite, then its diagonals are perpendicular. Alright? If ABCD is a kite, then segment CA is perpendicular to segment BD. As well as it has one pair of opposite angles that are congruent. And the pair of opposite angles that are congruent are the angles that are in between the non-congruent sides. So in this case, that's angle C and angle A. Okay? It has exactly one pair of opposite angles that are congruent. Alright? So, segment BC is congruent to segment BA. Alright, those two are congruent. So angle C is congruent to angle A, and angle B is not congruent to angle D. Okay? Alright, find the measure of angle T in the kite shown at the right here. Alright, so we know we have a kite. We're told it's a kite. So right away, we know the angles. We have one pair of opposite angles that are congruent, and it's these angles here. If I don't know angle T, and it's I call it X, well then angle R has to be X as well. So then what do we know? Well, we know it's a quadrilateral. We know the angles have to add up to equal 360 degrees. Combined length terms, 70 and 88, that's 158, plus 2x equals 360. Subtract 158 from both sides. 2x equals 202. Alright, divide by 2. X equals 101. Alright, find the measure of angle T. Well, angle T we called X. X is 101, so the measure of angle T is 101 degrees. Alright. And that is it. Thank you very much.